Hello viewers and fellow math students revising for their end of years. Welcome to my YouTube channel. Today, we'll be going through functions. In this video, you'll learn about how to solve three types of functions questions. Let's dive in. Firstly, we will look at question 1. The function f of x leaves a remainder of 10 when divided by x minus 3 and a remainder of negative 8 when divided by x plus 4. Find the remainder when f of x is divided by x squared plus x minus 12. In these types of questions, usually this quadratic expression given is factorizable, and the factors are in the question itself. So, x squared plus x minus 12 equals to x minus 3 times x minus 4. I mean x plus 4. This is the first step for this question, and it will be very important later. So now, we want to let the remainder when function of x is divided by this quadratic expression, x squared plus x minus 12 be a linear polynomial ax plus b. This is because when any quadratic expression where x is of any power is divided by a quadratic expression when x is power of 2, it will always give you a linear polynomial, as any x with powers above 2 or above, will be easily divided out. So what's left is x to the power of 1 and x to the power of 0, which is ax plus b. So f of x equals gx, where gx is another function, x minus 3, x plus 4, plus ax plus b. So this is the general equation to solve this question, where gx is another function, which we do not need to find because it is not needed in this question. So, since it leaves a remainder of 10 when divided by x minus 3 using the remainder theorem, f of 3 equals g of 3 times 3 minus 3 times 3 plus 4 plus a times 3 plus b. So essentially, we are finding an equation with a and b only, and 3 minus 3 equals 0. So this whole part with function g equals 0. This is why we do not need to find what is function g. So this gives you 3a plus b. So if we look at a new equation, 3a plus b will give you a remainder of 10. So 3a plus b equals 10. So we let this be equation 1. To solve any equation with two variables, we need to have two simultaneous equations. And this is why the other example is given. So if we look at the other example, since it leaves a remainder of -8 when divided by x plus 4 using remainder theorem, f of -4 equals g of -4, -4 minus 3, and we got -4 plus 4 plus a times -4 plus b. This is the same as the previous equation, as we do not need to find what's function g, as -4 plus 4 already gives you 0. So this whole part with function g inside it equals to 0. So what's left gives you -4a plus b. If we look again, we can see that a remainder of -8 is left when it is divided by x plus 4. So -4a plus b equals -8. This is our second simultaneous equation. So we are going to use the subtraction method. So subtract 2 from 1. You can also subtract 1 from 2, but I rather use 2 from 1 because I do not want a -a and a negative constant. So we will have 3a plus b minus -4a plus b equals 10 minus -8. So what we are doing is to subtract b away. So a and the constant are left in this equation. So we got 7a equals 18. So a equals 18 over 7. So we found a already. What's next? We need to find b. So we need to substitute a equals 18 over 7 into equation number 1. Or you can do it into equation number 2. But I rather substitute it into equation number 1 because I do not want to deal with negative numbers. So we've got 3 times 18 over 7 plus b equals 10. So we want to make b the subject of this equation, and we need to find b. So new equation, b equals 10 minus 3 times 18 over 7. And this will give you 16 over 7. We found a and b already. What's next? We need to find the remainder. So the remainder when f of x is divided by x squared plus x minus 12 equals ax plus b. And since we already found what is a and what is b, we need to substitute a and b back. So therefore, the remainder when function of x is divided by this quadratic expression x squared plus x minus 12 gives you 18 over 7 x plus 16 over 7. Done. This is the answer. So celebrate your 4 marks. And let's move on to the next question. Let's move on to question 2. The function f of x equals 3x to the power of 3, which is 3x cubed, plus 4x squared, minus 9x plus b, leaves a remainder of 2m plus 5, when divided by x minus 3, and a remainder of 4m minus 7, when divided by x plus 1. So, we must find the value of b and m. So, how do we solve this question? We must use the remainder theorem. So to use the remainder theorem, we must have a function, a remainder, and a divisor, which we already have. And we have 2 of them. So remainder theorem is needed in this question. So when function of x is divided by x minus 3, 2m plus 5 is the remainder. Using remainder theorem, function f of 3 equals 3 times 3 cubed plus 4 times 3 squared plus or minus 9 times 3 plus b. Which gives you 90 plus b. So same principle as number 1, 90 plus b gives you 2m plus 5. And this will be our equation number 1. So we need to have another Simon equation to find b and m. So when f of x is divided by x plus 1 for m minus 7 is the remainder. So using remainder theorem, function of negative 1 equals 3 times negative 1 to the power of 3 plus 4 times negative 1 squared minus 9 times negative 1 plus b. And this will be equals to 10 plus b. So same principle as the first sign out equation. 10 plus b equals 4m minus 7. And this is our equation number 2. So we've got two sign out equations already. So we must use the process of elimination. So we need to subtract 2 from 1. Same reason why I subtracted 2 from 1 in the first question. So I don't deal with negative numbers. So we got 90 plus b minus 10 plus b equals 2m plus 5 minus 4m minus 7. So we've got one negative number here, which is negative 2m, but I do not need to worry so much because it's only 1. So we've got 80 plus b. Oh, it's only 80. There's no b because I subtracted b already. Will give you 2m minus 4m will be negative 2m, and 5 minus negative 7 will give you 12. So 80 equals negative 2m plus 12. We plus 2m on both sides and minus 12 on both sides will give you 2m equals negative 68. I mean, if you minus 80 from both sides, you'll give 2m equals negative 68. My bad. So we can find m. M equals negative 68 divided by 2 equals negative 34. So what's next? Again, you must substitute m equals negative 34 into equation number 1, because I don't want to deal with negative numbers. So 90 plus b equals 2 times negative 34 plus 5. And we have another negative number. P equals negative 90, because we minus 90 from both sides to make b the only variable on the left side. So we got minus 90 minus 2 times minus 34, negative 34, plus 5 in plus. So it will give us negative 153. So we have found b and m already. The last step is our answer statement. It will be 1 mark. So b equals negative 153 and m equals negative 34. And this is our answer for question 2. Finally, let's dive in now to question 3, our last and final question. We need to solve x cubed minus 5x squared plus 16x minus 30 equals 0, and x must be a real number. A real number means that it is defined and is not and it is not an imaginary number. So why do you think this question is under functions? This is because we need to use a function to solve this question. So we let a function. You can use any alphabet you want from A to Z, but since F is the most common letter for function, we will let fx equals x to the power of 3 minus 5x to the power of 2 plus 16x minus 30. So here's a tip for all of you. If you go to your calculator, press menu and press equation, which is the key 5, and press polynomial, which is key 2, and select your polynomial degree. In this question, the polynomial degree is 3, and we key in the equation 1x to the power of 3 minus 5x to the power of 2 plus 16x minus 30. It will give you 3 solutions. Solution number 1 is 3. Solution number 2 is 1 plus 3i. And solution 3 is 1 minus 3i. We can only accept x equals 3 in this question because x is a real number as defined over here. So now, we know that x equals 3 is one of the solutions. So what do? You must try. Without trying, you can't find success. And without trying x equals 3, you can't find the answer. So x equals 3, and function of x equals, which is function of 3, equals 3 to the power of 3 plus minus 5 to the power 5 times 3 to the power of 2 plus 16 times 3 to the power of 1 minus 30. And this will give us 0. So using factor theorem, x equals x minus 3 is a factor of x to the power of 3 minus 5x to the power of 2 plus 16x minus 30. So now, you must simplify this cubic equation, into a quadratic equation plus a linear expression. So you must use any method you want. You can use any method you want to obtain the quadratic expression and linear, but I'll be using long division. So we have f function of x over x minus 3 equals x to the power of 3 minus 5x to the power of 2 plus 16x minus 30 over I can't click, never mind, x minus 3. I can't show the long division working here, but I think you'll be able to do long division. And it'll give you x to the power of 2 plus 2x minus 10. So we simplified this cubic expression into a quadratic expression times a linear expression. So what we need to do is write the new statement out. So x to the power of 3 minus 5x to the power of 2 plus 16x minus 30 equals x minus 3 times x squared plus 2x minus 10. So we've wrote it out. What can we do now? For starters, we can now solve it. So x minus 3 times x to the power of 2 plus 2x minus 10 equals 0. So we can now do x minus 3 equals 0, or x x squared plus 2x minus 10 equals 0. So we do not need the brackets on this one. So if we solve x minus 3 equals 0, you'll find that you get x equals 3. You may be asking me, when we already tried x equals 3, why do we need to show this working again? This is because teachers will mark based on your working and not based on your answer. Like, not primarily based on your answer. Because the answer is only 1 mark, while the working is 4 to 5 marks. So x equals 3. And we can see that the discriminant of this quadratic equation is less than 0. So we can write this down. Since discriminant equals b squared minus 4ac. So b in this case is 2 squared minus 4 times 1, which is a, and times negative 10. Oh, wait, it's a typo. This is supposed to be minus, and this is supposed to be plus. My apologies. So since discriminant is negative 2 squared, minus 4 times 1 times 10 equals negative 36, which is less than 0. X squared minus 2x plus 10 does not have any real solution. Therefore, x must only be equal to 3, and this will be our final answer. So this question teaches us to use our tools, which is our calculator, appropriately in our exam, as there are hidden features of the calculator which can be quote-unquote exploited in the exam, and to always check for careless mistakes at the end of each answer, at the end of each question, like me just now. I accidentally swapped the plus and minus symbols. So if you swap the plus and minus symbols in a question, it might lead to the whole question getting 0 if it was on the early part of the question, like this one. And I forgot to swap this. It teaches us to read the question carefully and to not make any careless mistakes, and to check after every question and do one final check at the end of the paper. Thank you for watching this video until the very end. Stay tuned for the next tutorial. Out.